Hello viewers, welcome to today's lesson. This is the solution space, the platform where mathematics is made easy and simple for everyone to understand and to enjoy. In this video, I want to solve a question that one of my followers on Facebook sent to me, and he asked that I help him solve it. And I want to solve it with all of you, and that's a question on the board. It's a question on circuit theorem, and I know that I've not treated circuit theorem with you. We've not done any video on it, but I still want to go ahead and solve the question with you. And later on, we are going to take circuit theorem as a full topic and treat it into details from the basics, okay, so that you get a good understanding of it. But in this video, I just want to solve the question with you, and I'm going to explain it, okay? So if you follow closely, you will definitely understand it, okay? So just do well to follow closely the explanation that I'm about to give on the question, and you will get a perfect understanding of it. And as I said, later on, we will take circuit theorem as a full topic and treat it into details, okay? And please don't forget to like the videos and also share them after watching. And if you are watching for the first time, please do well to follow the page and also subscribe to my YouTube channel. So let's go ahead and take a look at the question that I have on the board. Let's look at it and read it together, okay? So there's a diagram given, and it says that angle DCE equals to 56 degrees, angle ABE equals to 5s minus 16 degrees, and angle BAE equals to 3 over 2s plus 4y degrees. And it says that if angle DCE is to angle CDE, which is equal to 7:8, it says find A, angle AEB, and B, the values of S and Y. Okay, so the question is asking us to find angle AEB and also the values of S and Y in the diagram. Okay, so now the first thing to do, okay, to solve this question is that you have to first identify all the given values in the diagram. Okay, you can see that there's a diagram given here. So we are going to first identify all the given values in the diagram. Okay, that's the first step. Okay, that helps us to be able to solve the question. Okay, so we are going to first identify all the given values in the diagram. Okay, so let's go ahead and identify all the given values in the diagram, okay, one by one. Okay, so now we are going to start with this one. It says that angle DCE equals to 56 degrees. Okay, so we are going to identify the angle DCE from the diagram. Okay, now I've taught you how to identify angles in a diagram in some previous videos that I did. Okay, so we've learned about that, so we are going to apply that knowledge here to identify the angles in the diagram. Okay, but for the sake of those who don't have any idea on how to identify angles in a diagram, I'm going to do a quick recap on it so that we can proceed. Okay, so when we say that angle DCE equals to 56 degrees, so we have that angle DCE equals to 56 degrees. Now our focus is on the middle letter because the angle is always formed on the middle letter. Okay, I'm going to repeat it one more time. I'm saying that the angle is always formed on the middle letter, okay, or the middle point. Okay, so we have angle DCE equals to 56 degrees. It means that the angle 56 degrees is forming on the C, okay, because the middle letter is always where the angle is formed. Okay, we have angle DCE equals to 56 degrees, meaning that the 56 degrees angle is being formed on the middle letter, which is the C. The rest of the letters just help us to describe the angle. Okay, so assuming I have angle ABC equals to, let's say, 75 degrees. Okay, what it means is that the angle 75 degrees is being formed on the point B, okay, which is the middle letter. Okay, so when we say angle ABC equals to 75 degrees, it means the 75 degrees angle is being formed on the letter B. Okay, so the middle letter is our focus because that is where the angle is formed on. Okay, I hope the explanation is clear enough up to this point. So with this understanding, we are going to go to the diagram and identify all the values given, okay, in the question. Okay, so we are going to start with the angle DCE, which is 56 degrees. Okay, so let's go to the diagram. We have angle DCE, okay, which is given to be 56 degrees, which is the angle which is formed here. Okay, you can see that the middle letter is the C. Okay, so the 56 degrees angle is forming on the C, okay, the letter C. So angle DCE, talking about the angle which is formed here, which is 56 degrees. Okay, I hope the explanation is clear enough up to this point. Okay, let's go ahead and identify the rest of the angles. We also have that angle ABE equals to 5s minus 16 degrees. Okay, so let's identify that from the diagram. Okay, so we have that angle ABE. Okay, so the focus is on the middle letter, meaning that the 5s minus 16 degrees is being formed on the middle letter, which is the B. Okay, so let's go to the diagram ABE. Again, angle ABE, meaning that the angle which is formed on the B, okay, which is the angle being formed here, which is the 5s minus 16 degrees. Okay, I hope the explanation is clear enough up to this point. So let's proceed and also identify the next angle, which is angle BAE, which is equal to 3/2s plus 4y degrees. Okay, so let's look at it from the diagram. So angle BAE, okay, talking about the angle which is formed on the A, or the point A. Okay, so the angle being formed here, that is what we are referring to. Okay, angle BAE is 3/2s plus 4y degrees, the angle being formed here, angle BAE. So the angle being formed here. Okay, so that's it. I hope you understand up to this point. Okay, so let's proceed. It says that if angle DCE, so let's identify the angle DCE from the diagram. Say angle DCE, talking about this angle which is the 56 degrees, okay, is to angle CDE. So let's identify the angle CDE also. So angle CDE, talking about the angle which is formed here. Okay, don't forget the focus is on the middle letter. Okay, so we are looking at the angle which is formed on the letter D. So angle CDE. So the angle which is formed here, okay, which is this point, the angle which is formed here, that is what we are referring to. Okay, so that's the angle CDE, the angle which is formed here. So it says that if angle DCE is to angle CDE, which is equals to 7:8, find A, angle AEB, and B, the values of S and Y. Okay, so the question is asking us to find angle AEB and also the values of S and Y. Okay, so we are going to start by solving for the value of the angle AEB. Okay, that's the first part of the question. It says you should find angle AEB. Okay, so let's identify the angle AEB from the diagram also. Okay, so now let's go to the diagram. So this is the diagram. Let's identify angle AEB. Angle AEB. Okay, don't forget the focus is on the middle letter, okay, which is the E. Angle AEB. So we are looking at the angle which is being formed on the letter E. Okay, so AEB. So the angle which is being formed here, that is the angle AEB that the question is asking us to find. Okay, I hope you agree with me up to this point. Okay, so now let's proceed and start our solution. Okay, so I'm going to write my solution down, okay, and we are going to solve it together. Okay, so the first part of the question says that we should find angle AEB. Okay, and we've already identified the angle AEB from the diagram, which is the angle being formed here. Okay, now the next thing to do is that we need to consider where the angle AEB is being formed. Okay, because where the angle AEB is being formed will help us to know what to do to find the value of that angle. Okay, because it's important to know where the angle is being formed, okay, so that we can know what to do. Okay, so we are going to go back to the diagram and take a look at where that angle AEB we are looking for is being formed. Now if you take a good look at the diagram, okay, you can see that the angle AEB we are looking for, which is the angle being formed here, it is formed in a triangle. Okay, which triangle? Now I'm considering triangle CDE. You can see it's a triangle CDE. So the angle AEB that we are looking for is forming in the triangle CDE. Okay, now there are two triangles here, okay, in the sense that we can consider the big triangle being formed, which is the triangle ABE. Okay, that one is also forming a triangle AEB. Sorry, ABE instead. Okay, I'm talking about the big triangle. The big triangle is triangle ABE. Okay, but we are taking a look at the small triangle being formed in the diagram, and the small triangle is triangle CDE. I hope you agree with me. So that's the triangle that we are considering. We are considering the small triangle, okay, in the diagram, which is triangle CDE. And inside that triangle, we have the angle that we are looking for being formed inside. And the angle we are looking for is angle AEB. Okay, that's what the question is asking us to find, which is the angle being formed here. It is formed in a triangle, which is triangle CDE. So we are going to consider that triangle to be able to solve for the value of the angle AEB. I hope the explanation is clear enough up to this point. Now, the reason why I'm considering the triangle CDE is because we are going to apply a property, okay, under plane geometry. Okay, it says that the sum of the angles in a triangle is equal to 180 degrees. Okay, so when you add up the angles formed in a triangle, the interior angles in a triangle sum up to 180 degrees. So we are going to use that property to help us to find the angle AEB that we are looking for. That's why we are taking into consideration the triangle CDE. Okay, so that it can help us find the value of this side which we are looking for. I hope the explanation is clear enough up to this point. Okay, so now I'm going to write considering the triangle CDE, okay, because that will help us, because we are going to use the property which says that the sum of the angles in a triangle is equal to 180 degrees. So meaning that, please listen carefully, okay, meaning that the angle here plus the angle here plus the angle here should be equal to 180 degrees. Don't forget, you are considering the triangle CDE, and we've established that under the plane geometry we know that the sum of the interior angles of a triangle is equal to 180 degrees, meaning that when you add up the angles formed in a triangle, is equal to 180 degrees. So meaning that the angle here plus the angle here plus the angle here should give us 180 degrees. Okay, but the thing is that if you look at the diagram carefully, considering the triangle CDE, we don't know the angle which is formed here. We don't know. So we need to find that angle, okay, before we can proceed. Okay, which is the angle CDE. We don't know this side. We don't know that angle. Okay, so we need to find this side, okay, the angle which is formed here, before we can proceed and find this place, which is the angle AEB that you are looking for. Okay, I hope the explanation is clear enough up to this point. All that I'm saying is that we are using a property which says that the sum of the angles in a triangle is equal to 180 degrees. Okay, and considering the angle that we are looking for, which is the angle AEB, which is the angle being formed here, we need to consider the triangle CDE. Okay, so when we consider the triangle CDE, we can say that the angle here plus the angle here plus the angle here equals to 180 degrees, and that will help us to find this side that you are looking for. But we don't know the angle which is formed here, so until we find the angle which is formed here, we cannot go ahead and add this plus this and equate it to 180 degrees. We cannot do that. Okay, so we need to find the angle here before we can proceed and add the angles formed inside the triangle CDE and equate it to 180 degrees. That will help us to know this side that you are looking for. Okay, so the first thing is that we need to find the angle which is formed here, which is the angle CDE, talking about the angle here. Okay, now from the question, something has been given that will help us find the angle CDE. So we are going to make use of that, and that is the information given here. It says that if angle DCE is to angle CDE, which is equal to 7:8. Okay, so the angle CDE that we want, which is this angle, okay, we can find it from this given equation. Okay, so we are going to make use of that. I hope you agree with me up to this point. Okay, so I'm going to take that information, that equation given. It says that angle, I hope you are following, okay? It says that angle DCE is to angle CDE, which is equals to 7:8. Okay, so we are going to make use of this equation, okay, to find this angle that you are looking for, which is the angle CDE. Okay, I hope you understand up to this point. Okay, now you should know that we can express ratio as fraction, okay, because the equation given, it contains ratio, okay, and we can express ratios as fractions. So when you have, let's say if I have 2:3, it can be written as 2/3. Okay, the first number becomes the numerator and the second number becomes the denominator. Okay, so if I have A:B, it can be written as A/B. Okay, so the first value, which is the A, becomes the numerator and the second value becomes the denominator. So ratios can be expressed as fractions. Okay, so we are going to apply that knowledge to write the ratios in this equation as fraction. That's the next step. I hope you understand up to this point. So let's proceed. I'm going to clean this so that we can proceed. Okay, so I'm going to write this as angle DCE over angle CDE equals to 7/8. I hope you understand and you agree with me up to this point. All that we did is to express the ratios that we have in the equation as fractions so that it can help us solve further. Okay, now we know the value of one of the angles. Okay, it has been given, so we will substitute it into the equation. Okay, we know that the angle DCE has been given. Look, we have that angle DCE equals to 56 degrees. So in place of this angle DCE, I'm going to put my 56 degrees there. Okay, so let's go ahead. So I'm going to have 56 over angle CDE equals to 7 over 8. I hope you understand and you agree with me up to this point. Okay, we just substituted the value of the angle DCE into the equation. Okay, now when you have an equation like this, what you do is that either you multiply through by the LCM or you cross multiply. Either ways you get the same answer. Okay, so I prefer that you cross multiply, but if you choose to multiply through by the LCM too, it's the same thing that you are going to get. Okay, so I'm going to cross multiply now. Okay, so we are going to cross multiply. So we are going to have 7 times angle CDE. So we are going to write it as 7 angle CDE, okay, equals to 56 times the 8. I'm going to write my 56 times 8. I hope you understand and you agree with me up to this point. Okay, we just cross multiplied. Okay, so 7 times the angle CDE gives 7 angle CDE, and the 56 times the 8, I'm writing 56 times 8. You can just multiply and put the value there. It's the same thing, okay? I just don't want to work with big values. That's why I've maintained it as 56 times the 8. Okay, so if you choose to put the value for multiplying the 56 times the 8 here, it's the same thing. Okay, I just don't want to work with big values because when we divide through by the 7, you can see that the simplification will be much easier. Okay, so that's why I wrote it in this form. Okay, so let's proceed. To get my angle CDE, I'm going to divide through by 7, the equation by 7. So I'm going to divide here by 7. I hope you agree with me. And I'm going to divide here also by 7, so that this 7 and this 7 can cancel. Then 7 goes here 1, 7 goes into the 56 8 times. Okay, so I'm going to get that my angle CDE equals to 8 times 8. It gives 64. So I'm getting 64 degrees. Okay, so the angle CDE is 64 degrees. Angle CDE, talking about the angle here, is 64 degrees. Okay, now that we've gotten the angle which is supposed to be here, now we can proceed and apply the property which says that the sum of the angles in a triangle add up to 180 degrees to be able to find this side that you are looking for, which is the angle AEB. I hope you agree and you understand up to this point. So let's proceed. Okay, so I'm going to say that my angle CDE plus, okay, talking about this angle plus this angle, which is angle DCE, plus the angle AEB that I'm looking for, which is the angle being formed here, plus the angle, I forgot to bring my angle here, so let me bring the angle. Okay, so you need to bring the symbol of the angle. So angle DCE plus angle AEB, okay, should be equal to 180 degrees. And I hope you understand up to this point. Okay, now we are going to input our values. We know that angle CDE is 64 degrees, so I'm going to write my 64 degrees plus my angle DCE is 56 degrees plus the 56 degrees plus the angle AEB that I'm looking for, which I don't know, equals to 180 degrees. I hope you understand up to this point. Okay, so now this is just a linear equation to solve. Okay, let's simplify this, and this 64 degrees plus the 56 degrees is going to give me 120 degrees, and I hope you agree with me. You can do your addition to confirm and see. Okay, so this plus this, you are going to get 120 degrees plus the angle AEB equals to 180 degrees. Okay, so I'm making the angle AEB the subject. I've taught you linear equation, so we are applying that knowledge here. Okay, so if you don't have any idea on how to solve linear equation, just search for my videos that I've done on the linear equation. I've treated linear equation as a full topic. Okay, we've looked at a lot of examples on it, so search for those videos either on Facebook or YouTube and watch it so that you can get a good understanding of it. So let's proceed. So my angle AEB will be equal to this 120. We'll cross the equal sign to come and join the 180, which is here. But don't forget that when anything crosses the equal sign, the sign it has changes. Okay, it is positive here. When it crosses the equal sign, it becomes negative. Okay, so I'm going to have 180 degrees minus 120 degrees, and I hope you understand up to this point. Okay, so I'm going to get my angle AEB equals to 180 degrees minus 120 degrees gives 60 degrees. Okay, so that is the answer for the angle AEB that the question is asking us to find. Okay, which is the first part of the question. It says A, we should find angle AEB, and angle AEB is equal to 60 degrees. I hope the explanation is clear enough up to this point. Okay, so we know that this angle AEB, the angle here, okay, is 60 degrees. Okay, let me just write it there, okay, so that we can make reference to it. Okay, it's 60 degrees, and the angle here we saw for it also, which is 64 degrees, which is the angle CDE, is 64 degrees. Okay, so I just place the values there so that we can easily make reference to it. Okay, because I'm going to clean a portion of the board for us to continue because I need more space. Okay, so now let's come to the B part of the question. It says that we should find the values of S and Y. Okay, so we need to consider where the variables S and Y are in the diagram. Okay, so looking at the diagram, you can see that we have a quadrilateral in a circle here. Okay, look at a quadrilateral A, B, C, D. Okay, so we have a quadrilateral in a circle and we call it cyclic quadrilateral. Okay, so maybe someone is wondering what is a cyclic quadrilateral. In simple terms, when we speak of a cyclic quadrilateral, it means that we have a quadrilateral which is inscribed in a circle such that the vertices of the quadrilateral touches the circumference of the circle. I hope you get it. I want to go over one more time. When we speak of a cyclic quadrilateral, okay, in the case of this one, we have a quadrilateral which is inside a circle. So we call it a cyclic quadrilateral. And a cyclic quadrilateral means that we have a quadrilateral which is inscribed in a circle, meaning that in a circle, okay, such a way that the vertices of the quadrilateral touches the circumference of the circle. So you can see that the quadrilateral A, B, C, D, okay, the vertices are touching the circumference of the circle, okay, and the quadrilateral is inscribed in a circle. Okay, so we are going to consider this part of the diagram to find the values of S and Y, because the S and Y that you are looking for, they are in the quadrilateral A, B, C, D. So we need to consider that quadrilateral. I hope the explanation is clear enough up to this point. Okay, so now let's look at the angles in it. We have that the angle here is 3/2s plus 4y degrees. And we also have that the angle here is 5s minus 16 degrees. Okay, so we are going to apply a property, okay, on quadrilaterals. Okay, it says that the sum of the opposite angles in the quadrilateral is equal to 180 degrees. Okay, I'm going to repeat it one more time. The property that you are going to apply here says that the sum of the opposite angles in a quadrilateral is equal to 180 degrees. What it means is that the angle formed here plus the angle which is formed here, okay, which is angle BCD, talking about the angle formed here. When we add the angle here plus the angle here, it should be equal to 180 degrees, okay, and also the angle here plus the angle which is formed here, which is angle ADC, the angle which is formed here, okay, when we add them, it should be also equal to 180 degrees. So that's a property that we are going to use to be able to solve for the values of S and Y, okay, in this cyclic quadrilateral. Okay, one more time, the sum of the opposite angles in a quadrilateral is equal to 180 degrees. Okay, so keep that in mind. So the angle here plus the angle formed here, okay, let me indicate it. So I'm talking about the angle which is formed here, which is the angle BCD, the angle formed here. Okay, so this angle plus this angle equals to 180 degrees, and also the angle here plus the angle formed here, which is angle ADC, okay, the angle which is formed here. Okay, let me indicate it. The angle which is formed here, we add this and this, it should also be equal to 180 degrees. Okay, so that's the property that you are going to use. But before we can proceed and use that property to find the values of S and Y, we should take note that we don't know the angle which is formed here. We don't know, so we need to find it. And also the angle which is formed here also, we don't know as well. So we need to find the angle formed here and also the angle formed here before we can proceed and use the property which says that the sum of the opposite angles in a quadrilateral is equal to 180 degrees. I hope you understand and you agree with me up to this point. So we need to find the angle which is formed here, and that will lead us to another property also, because we need to use another property to find the angle which is formed here. And that property is under plane geometry. It says that the sum of the angles on a straight line is equal to 180 degrees. So angles on a straight line add up to 180 degrees. So keep that in mind. We are going to apply that. So we are going to consider this straight line and use the property which says that the sum of the angles on a straight line equals to 180 degrees to find the angle which is supposed to be here. And also we are going to use that same property to find the angle which is also supposed to be here, because this angle and this angle, they are on a straight line as well. Okay, so the angle here plus the angle here will be equal to 180 degrees. Okay, then also the angle here plus the angle here will also be equal to 180 degrees. Okay, then we'll get our values for the angles which are supposed to be here and here. Then we can proceed, okay, and apply the property which says that the sum of the opposite angles in a quadrilateral equals to 180 degrees. Then we use it to solve for the values of S and Y in the diagram. I hope the explanation is clear enough up to this point. Okay, so I need more space to continue, so I'm going to clean a portion of the board. Okay, so I'm going to clean this side so that we can continue and solve. Okay, so I'm going to clean this from here so that we can proceed with our solution. Okay, so don't forget, we are trying to find the angle here and also the angle which is formed here. Okay, we are using that the angles on a straight line add up to 180 degrees. Okay, so the angle here plus the angle here equals to 180 degrees so that we can find the angle which is supposed to be here. Okay, so let's name the angle which is here. Okay, we can name it angle BCD. Okay, talking about the angle which is here. So we have that the angle BCD plus this angle, the angle from here, which is angle DCE, the angle which is formed here. Okay, angle DCE should be equal to 180 degrees. I hope you agree and you understand up to this point. Okay, all that we are doing is to find the angle which is here and also the angle which is here, and for us to achieve that, we are using a property under plane geometry which says that the sum of the angles on a straight line is equal to 180 degrees. Okay, so the angle here plus the angle here, and we name this angle angle BCD, okay, talking about the angle here, plus the angle here, which is angle DCE, okay, equals to 180 degrees. Okay, so now let's just input our values and solve for the angle BCD that you are looking for. Okay, so we don't know this angle, that's what you are looking for, which is the angle BCD. So I'll just repeat my angle BCD plus the angle DCE. We know its value. Okay, angle DCE is given to be 56 degrees. Okay, so I'm going to put my 56 degrees there, equals to 180 degrees. Okay, and this becomes a simple linear equation to solve for the angle BCD that we are looking for. Okay, so we are going to do our angle BCD will be equal to 180 degrees minus 56 degrees, and I hope you agree with me up to this point. Okay, so this is positive 56. It will cross the equal sign. When anything crosses the equal sign, the sign it has changes. Okay, it's positive here, it crosses the equal sign, becomes negative. Okay, that's why we are having this. Okay, so I have that my angle BCD will be equal to 180 degrees minus 56 degrees. That will give you 124 degrees. I hope you agree with me. Okay, so just do your subtraction to confirm. Okay, 180 degrees minus 56 degrees, we have 124 degrees. So our angle BCD, which is this place, okay, let's label it this place. Okay, we have it to be 124 degrees. 124 degrees. Let me just indicate it there, okay, so that we can make reference to it. I hope the explanation is clear enough up to this point. We need to proceed also and find the angle which is supposed to be here. Okay, so still using the property which says that angles on a straight line add up to 180 degrees. You are going to find this side. So the angle here, we can name it, let's name it angle ADC. Okay, so angle ADC, talking about the angle here plus the angle which is here, which is angle CDE. We add them, this angle plus this angle is equal to 180 degrees. Okay, then we'll find this angle. Okay, so let's proceed and do that also. So I'm going to label this angle as angle, I hope you are following. Okay, so we also have that our angle ADC, angle ADC plus angle CDE, talking about the angle here. So angle CDE should give us 180 degrees. I hope you understand and you agree with me up to this point. Okay, so let's just input our values and solve. Okay, so we are solving for angle ADC. So I'm going to maintain my angle ADC that I have here plus the angle CDE. We know its value. Okay, angle CDE is given to be 64 degrees. We solved it here. Angle CDE equals to 64 degrees, which I've labeled it here also as well. 64 degrees. I hope you understand. Okay, so I'm going to put my 64 degrees there, equals to 180 degrees. Okay, and we just make our angle ADC the subject. So angle ADC will be equal to 180 degrees minus 64 degrees. Okay, because it's positive here. When it crosses the equal sign, it becomes negative. Okay, so now let's conclude and write our final answer. So I have my angle ADC will be equal to 180 minus 64 degrees. It will give you 116 degrees. I hope you understand and you agree with me up to this point. Okay, so we have our angle ADC equals to 116 degrees, which is this part. Okay, so let's label that part as well. Okay, so we have this part to be 116 degrees. Okay, I hope you understand up to this point. Now we can proceed now and apply the property, okay, which governs a quadrilateral. It says that the sum of the opposite angles equals to 180 degrees. Okay, so we are going to apply that to solve for the values of S and Y, because the S and Y, they are inside this quadrilateral A, B, C, D. Okay, so I need more space to continue, but I hope the explanation is clear enough up to this point and you understand as well. So I'm going to clean a portion of the board again, okay, so that we can continue. Okay, the solution is lengthy, but I hope the explanation is clear enough and you understand it. Okay, so let's go ahead and clean a portion of the board so that we can continue. So I'm going to clean this side, okay, so that we can continue from there. Okay, so we are going to consider the quadrilateral ABCD. Okay, so I'm going to write considering the quadrilateral ABCD. Okay, so ABCD. I hope you agree with me. So we are considering that quadrilateral ABCD. Okay, so I think it's not clear, so let me clean it and write it here so that you can see. Okay, so considering the quadrilateral ABCD, okay, we have that the sum of the opposite angles in a quadrilateral equals to 180 degrees. That's a property that we are applying. Okay, so keep that in mind. So I have that the angle here plus the angle here should be equal to 180 degrees. And also the angle here plus the angle here should also be equal to 180 degrees. Okay, so we are going to do exactly that. Okay, so now let's go ahead and start with this one, the angle here. Okay, so I have that this angle, which is angle BAE. Okay, so the angle BAE plus the opposite angle, which is this angle BCD. Okay, we solve for angle BCD, which is the 124 degrees. So plus angle BCD should be equal to 180 degrees. I hope you understand and you agree with me up to this point. Okay, we are just applying the property which says that the sum of the opposite angles in a quadrilateral equals to 180 degrees. Okay, so let's go ahead and input our values. Okay, we know angle BAE is given. This is the value of angle BAE given to be 3/2x plus 4y degrees. Okay, which is this angle, the angle which is from here. Okay, so I'm going to input the value which is 3/2x plus 4y. Okay, then plus the angle BCD. We've solved for angle BCD. Angle BCD equals to 124 degrees, which is this part. Okay, because it's this angle plus this angle, which is equal to 180 degrees. So I have plus 124 degrees equals to 180 degrees. I hope you understand and you agree with me up to this point. Okay, so let's go ahead and simplify further. I'm going to let this one cross the equal sign to this side. So I'm going to write my 3/2s plus my 4y equals to 180 degrees minus 124 degrees. I hope you understand up to this point. Okay, so let's go ahead and simplify further. Okay, so I have my 3/2s plus 4y equals to 180 degrees minus 124 degrees. Okay, let's do it and see what we get. 180 minus 124. Okay, so you borrow 1 from here, add it to here, here becomes 10, 10 minus 4, 6, here is 11 is 7, 7 minus 2, 5, 1 minus 1 is 0. So we are going to get 56. Okay, I hope you agree with me. So 180 minus the 124 degrees, okay, it's going to give me 56 degrees. So I'm going to get 56 degrees. Okay, so now what do we do from here? We just need to multiply through by the LCM. I've taught you linear equation. Okay, we've treated linear equation as a full topic, so we are applying that knowledge here. So I explained to you that anytime you have an equation that contains a fraction, the first thing to do is that you multiply through by the LCM. So we are going to do exactly that here. Okay, so the LCM is the value that we have at the denominator, which is a 2. So the LCM is 2. So we are going to multiply through the equation by the LCM, which is 2. I hope you understand. Okay, so each term in the equation, we are going to multiply it by 2. Okay, so I'm going to multiply this term by 2, this also by 2, and this also by 2. Okay, so let's go ahead. So I'm going to have 2 times 3/2 2s, I hope you understand, okay, plus 2 times 4y equals to 2 times 56 degrees, and I hope you understand up to this point. Okay, so now let's go ahead and do some simplification. These 2 and these 2 will cancel. Okay, so let's continue. I need more space again. Okay, so I have to still clean a portion of the board. Okay, so please bear with me, but I hope you understand. Follow the solution. Okay, so I'm going to clean this side so that we can continue. Okay, so let's go ahead. Okay, so I hope you understand. So I can clean this side. So I'm going to clean this side of the board so that we can continue. Okay, so I have my 3s left here. Okay, so I'm going to write my 3s plus 2 times the 4y is going to give 8y equals to the 2 times the 56. Okay, is going to give, let me do it so that I don't make a mistake. I just want to be sure of it. So I have 56 times 2. Okay, this times is 12, 2 remainder 1, this times is 10 plus the 1, 11. So we are going to get 112, okay, degrees. Okay, so I have my 3s plus 8y equals to 112. I hope you understand and you agree with me up to this point. Okay, so I'm going to now label this one as equation 1. Okay, I hope you agree with me. Okay, so we are labeling it as equation 1 because we have 2 variables in this equation. Until we know one of the variables, we cannot proceed to solve, okay, for any of the variables. So we label it as equation 1. Let's proceed and do the other one also. This angle plus this angle will be equal to 180 degrees, and we'll solve for the value of s in that one. So let's go ahead. So I have that. Let's label this angle. So I'm going to label it angle ABC, okay, which is this angle, plus this angle, okay, which is angle ADC equals to 180 degrees. And I hope you understand and you agree with me up to this point. So we are just going to input our values. Okay, so let's do exactly that. I have this angle ABC, okay, talking about this angle ABC is given to be 5s minus 16 degrees, okay, or angle ABE. Maybe someone is confused. Why am I saying angle ABC instead of angle ABE? Because the question gave us angle ABE. Okay, now it's the same. Okay, so in order for you not to get confused, let's just maintain what the question gave us, which is the angle ABE, okay, which is actually the same as me saying angle ABC, okay, either angle ABE or angle ABC is the same, referring to this angle. Okay, so let me make here E, okay, so that no one gets confused about it. So I'm going to make here E. Okay, so we have that the angle ABE is given to be 5s minus 16 degrees. So in place of it, I'll put my 5s minus 16 degrees there, then plus the angle ADC. We saw for angle ADC, angle ADC, talking about the angle here, which is 116 degrees. So plus 116 degrees equals to 180 degrees. I hope you understand and agree with me up to this point. All that we did is to input the values. Okay, we first did the addition of this angle and this angle equals to 180 degrees, and we are just inputting the values. We know here to be 116 degrees. I've written it there. We've already solved it, but I've cleaned that part. That's why you are not seeing the solution on the board, but we've already solved it, and we know that this part, the angle here is 116 degrees, and also this angle is 5s minus 16 degrees. So we are adding them and equating it to 180 degrees because we are applying the property which says that the sum of the opposite angles in the quadrilateral is equal to 180 degrees. So the angle here is opposite to the angle here. So this angle plus this angle equals to 180 degrees. That's why we are having angle ABE plus angle ADC equals to 180 degrees, referring to this angle which is the angle ABE and this angle which is the angle ADC. We add them up because 180 degrees. We input the values and we are arriving at this. So I hope you understand up to this point. Now let's proceed and simplify further. Okay, so I'm going to repeat my 5s minus 16 degrees plus 116 degrees will give me a positive 100 degrees, and I hope you agree with me, equals to 180 degrees. So my 5s equals to 180 degrees minus 100 degrees. So my 5s equals to, when you subtract, you get 80 degrees. I hope you understand up to this point. And for us to get the value of s, we divide through the equation by 5. Here also by 5. So here and here cancel. The 5 here and this 5 cancel. 5 goes here 1 and 5 goes into the 80 16 times. Okay, so 5 goes into 80 16 times. Okay, you can confirm, do your division and confirm. So 5 goes here 1 and 5 goes into the 80 16 times. So we have that our s. Okay, so I need more space to continue, so I still need to clean a portion of the board. Okay, so please bear with me. It's just that the solution is a bit lengthy but very simple. I hope you are following the explanation and you understand. Okay, so I'm going to clean this portion so that we can continue. Okay, so I'm going to clean this side. Okay, let me clean this portion for us to continue. Okay, so I have that my s, so my s equals to 16 degrees. Okay, we are being asked to find the values of s and y in the diagram. Now we've gotten the value for s, which is s is equal to 16 degrees. So we are going to put that value into equation 1, okay, to solve for y also. Okay, so I'm going to write putting s equals to 16 degrees into equation 1. Okay, so the equation 1, we have that 3s plus 8y equals to 112 degrees. Okay, now the value of s is 16, so wherever I see s in this equation, I'll put the 16 there. I hope you agree with me. Okay, so I'm having 3 multiplying the s, the value of s is 16, so 3 times 16 plus 8y equals to 112 degrees. Okay, this times is 3 times the 16 degrees. Let me bring my degrees. 3 times the 16 degrees, it will give me 48 degrees. And I hope you agree with me. Okay, then plus the 8y equals to 112 degrees. I hope you understand and you agree up to this point. Okay, so let's solve for y. So I will maintain my 8y equals to 112 degrees minus 48 degrees. Okay, I hope you understand. So my 8y, this is just a linear equation that you are solving for now. Okay, so I hope you understand. Okay, so let's do our subtraction. 112 degrees minus 48 degrees. Okay, so let me do the subtraction just to be sure of it so that you don't make any mistakes. So minus 48. So this minus this is not possible. We join the 1, becomes 12. 12 minus 8, we have 4. Here is left with 0, so which is, we join the 1 to it, becomes 10 minus 4, it gives us 6. Okay, so we'll get 64. I hope you agree with me. Okay, so the 112 degrees minus 48 degrees, it gives us 64 degrees. Okay, and for us to get our value for y, we divide through the equation by the coefficient of y, which is the 8. Okay, so I'll divide here by 8. I hope you understand. And divide here also by 8, so that this 8 and this 8 will cancel. Okay, so I have 8 will go here 1 and 8 goes into the 64 8 times. Okay, I hope you understand. So we have that my y, okay, let me continue from here. So I have that my y equals to 8 degrees. Okay, I hope you agree and you understand up to this point. We are dealing with angles, so it's necessary you bring your unit, which is the degree. So we have y is equal to 80 degrees and we have s equals to we solve for the value of s. What's the value for s? S is equal to 16 degrees, which is here. Okay, s is equal to 16 degrees. So let's conclude. So therefore Okay, let's just write our conclusion here. So therefore, we know that our s equals to 16 degrees and also y equals to 8 degrees. Okay, so this is our final answer for solving for the values of s and y in the given diagram. Okay, I hope the explanation was clear enough and you understood it as well. It's a lengthy solution, of course, I know, but the explanation, I hope it was clear enough and it was simple for you to follow. Okay, so I hope you understood it and you enjoyed the lesson as well. Please don't forget to like the video and also share the video. And if you are watching for the first time, please do all to follow the page and also subscribe to my YouTube channel. I'll see you again in another video whilst we solve other questions as well and treat new topics. Bye bye.